Good morning, everyone. Good morning. This is Ali Daneshy, and we're having a webinar this afternoon, excuse me. Well, this afternoon for me. I imagine for Dr. Firuzabadi, it's still in the morning. We're going to have a webinar today to discuss some of the conditions of the oil and gas industry, and in particular, the situations that we are faced with today. The webinar would primarily been presented by Mr. George King. I don't think George needs any introduction. He's one of the giants of our industry, and he has been in the business for a long time, has worked with multiple companies, and his knowledge is known worldwide. So whatever I say is not going to add to his global reputation anyway. So with that, the topic is going to be prospects and projects for development of tight oil and gas plays. I'll ask the questions, and George will answer the questions. And as we go, if necessary, I may jump in and say a couple of words. But if you have got any questions, please go ahead and send your questions through the chat, and they will come to me, and I will ask them from George. So, George, thank you very much for agreeing to join us. And the first question that comes to everybody's these days is, why are the finding and development costs so high in low permeability reservoirs? I think that's a point that needs to be understood by the audience.
All right. What we're seeing in the industry, and this has been since about the mid-90s, mid-late 90s, early 2000s, is that we are really having to contact more and more of the reservoirs that we have open to us, which is the conventional reservoirs were relatively easy and inexpensive. But as you drill more and more wells, and we're having to drill a considerable number of wells to get the background or the base load carried in our supply of oil and gas, especially within the United States, but in other countries as well. And whereas drilling used to be 70% of the cost of a well, with fracturing as a minor expense, it's reversed itself, and now fracturing is 70 to 80% of the total cost of the well, and drilling is 20 to 30%. Drillers have managed to get their costs down and keep them down because they're picking up information, they're doing a lot of research on directional drilling, and it's getting quite a bit better. Fracturing, on the other hand, seems to be a remedy that people want to use to try to make a bad reservoir into a good well. And again, we've been successful in shales, but only in parts of the shales have the wells been actually economic and really tapped in and are draining a significant amount of the reserves in place or the resources in place. So one of the things we really have to look at is what's costing us the most and how effective is it? And I think if we work on those two things, and most of that is done by fracturing, increasing the amount of contact, but also looking at why we're getting into these very, very rapid declines. Most of it is just a dual permeability type reservoir in which the fractures, fissures, natural fractures are really being produced, and the recharge of those is very, very slow. Now, that's part of the reason, but the other piece of that is that the flow paths, these micro cracks, the fissures, the natural fractures, are not getting propped effectively. And there was a paper presented by Carl Montgomery in the fracturing symposium this last winter, that really looked at some of the micropropants that are coming out, and they didn't really see benefit of those micropropants until you got out to 7 months to 12 months. And then it was very startling to see that the decline rates were much slower, much lower, less in those wells that use the micropropant. And they've done quite a bit of research on that, but I would direct us back to that paper as this could be one key to this. The other part is we need to figure out which part of the reservoirs are best and for the technology that we have today. Other parts of the reservoir may work, but the technology isn't there yet. And of course, in the oil industry, we are developing technologies all the time. So I think what the bottom line and the conclusion of that question would be is we need to understand where to drill, how to frack, and the final thing there is how to effectively produce these reservoirs using this developing technology. And the oil industry sometimes is very, very cautious about adopting new technology. They want to see instant results. Well, things like the micropropant and how you produce a well don't provide instant results, but they do provide results over time. And I think that is one thing, one major thing that we need to do to decrease the finding and development costs simply by producing much more oil and gas out of those areas.
Excellent. And I may add that another factor that contributes to this is the fact that there is the initial investment that needs to be made to find these planes is quite expensive, and it doesn't always show a promise. There are many times with many wells that have been drilled with the expectation of finding a reserve and have turned out to be dry. So there is another aspect of it, which is the risk of it. The next question would be, what are the various approaches which are used by different large and small companies for development of these plays? What kind of approaches do they usually use for these?
Okay, that one is really, it's a view of some of the best and the worst practices that we do. In very small companies, they are dependent on a very high rate of flow just to justify the next well, and whether they're borrowing money, whether they're spending their own money, and we're paying too much attention to the initial production and not enough to the ultimate recovery. Now, if you look at the two sets of companies that we have operating today in the United States, we have about 40 companies, super majors, big independents, really some of the smaller independents that really use the technologies. And these are really scattered all over. They're somewhat concentrated in the Permian Basin, but these companies pay attention to the technologies, but there are only about 40 or so of these companies, and you would recognize most of the names. On the other side, and before I leave that, they account for about 50% of fracturing that's done in the United States. And I don't know too much about other countries there, but this is the way many of those operate. On the other side of that, 40 companies doing about half, you have 6,000 small companies, poorly bankrolled. They're operating on a very slim budget, and they're depending on getting that high rate to justify the next well. That is a target group that really needs to understand the benefit of these technologies, and to understand it, we're going to have to do better at explaining, training, giving examples. And sometimes, and I've gotten involved in this with many small companies, just getting them to really evaluate what they're doing, you know, don't sweep it under the rug if it's a failure, really get it and talk about the failures. And this is one thing, Ali, that I know that you've talked about before in the SPE. We don't talk nearly as much about the failures as we should. And that's where you really learn. And when we can get learnings shared without scaring the stock market, that's going to be a big factor here in delivering technology and making it work in the field.
Yeah, one of the important aspects of this is the source of funding. The major oil companies have got, you know, a well-established source of funding, and their stockholders and supporters and their own financial strength provides the money which is needed for development of these reservoirs. Small and medium-sized companies generally run based on borrowed money. And in order to be able to borrow money, you need to prove that your investment, if the bank is investing in this, they need to prove to the bank that they have the potential to return the investment and return the interest on it, and that it will be a good venture to undertake. And so that's a big difference between them. And that's one of the reasons that these smaller and medium-sized companies do not have much tolerance for risk. They generally depend on somebody else having done it and proven it, and then they just go ahead and copy it and try to use it. Now, there are exceptions to this. There are some small companies that are actually quite willing to do this, but by and large, there aren't many of them who have got any kind of tolerance for taking risk. Next question is, what objectives must engineers reach to prosper in the downturn environment? What would be advised the audience, especially most of them, the young ones, to consider as they plan and they prepare for the future?
During any downturn, it's an opportunity to develop technologies, to learn technologies, and to dig through the papers in the SPE database, or one Petro, for example, which covers 17 or 18 different engineering and science communities. And when you do that, that should be one of the first things that you take up. Get an idea where the industry is heading and get educated in terms of what is going to be needed. I would suggest any one that's out there, publish when you have something that is unusual, that you see can be helpful to some of these other operators, and get your name out front. There are a couple of other things that I would go into is train, get training, and also develop training. And one of the things that we have not done really well is we let the service industry take over a lot of the training. And I'm not saying anything bad about their training, except they focus on their products. There are many cases where you could cut a lot of money off something by doing a job with known simple methods if you understand them. So as you understand them, and this is something that I have done, I'm starting into my 50th year in the industry since joining Amoco in 1971. As I look at this, as every time I learn something, I make a slide or a couple of notes, write it down. I've used PowerPoint repeatedly, and the number of files that I have in PowerPoint, I counted up the slides of all these files, these hundreds and hundreds of files that I have, and it was approaching 20,000 slides. Now, some of them are duplicates, but this is something when somebody asks me about, what can you tell me about stuck pipe, back off operations, tubing cutting, perforating, I can literally open up several files, and within an hour or two, I can put together 20, 30 slides for a talk that is right down to earth, that gives examples of doing it right and doing it wrong. And you can see why it fails. And as engineers, when we talk about what do we need for training, we need to train ourselves to think like an engineer. You see a problem, don't fence it off and cover it up or find an easy solution to it. Understand the issue as you go forward. I taught for 11 years at night at the University of Tulsa in the petroleum engineering area, a course for senior level and graduate level. And I was amazed at the number of people that really did not understand the basics of how to apply it. They understood the theory to a point, but they could not make that theory into a practice that you could actually use on a well. And at that point, I learned that some people just take big jumps of understanding, and there's really a lot of space between their footsteps in terms of lack of understanding. So think like an engineer. Look at a problem, understand the problem. When you understand that problem, you can find several ways to actually solve that problem. And that's what we're really looking for today, is to really understand. So that would be the piece in there of, when you're in a slump, don't waste your time. Put together a program to where you're going to become more informed on the problems, on the solutions, and on the technical advances that need to be made to make this startup as we start up again. And, I've seen many of these sinusoidal curves that go up and down, bust to boom. And people that come out of those the fastest are those that have enough knowledge about, okay, what do you do next? And that's something that we don't have to have a crystal ball for that. We can see where the things are failing and where they're succeeding. How do you make it better? How do you understand the failures and improve the successes?
If I may add to that, I get into this discussion many times when I was teaching at the university. And I always used to tell my students, you do something, the quality of your work represents who you are. If the work that you do is high quality, that means that is the kind of work that you do, and that is an indication of your value and your principles. You don't do a job because it's a job and you're getting paid for it. You do it because that is a representative of who you are. And I want to emphasize what George has just said, and that is, in every organization, when you go there, you will see there are areas of need. There are areas in which the organization is efficient. They're looking for guidance. They're looking for new information. It's important to keep our eyes open, identify what those areas are, and then understand them. And as George mentioned, and I've emphasized that, read the literature. You'll be surprised how much published literature there is in just about every subject that we deal with every day. And reading the literature and then just thinking about it and consulting with others and talking with others, you are most likely to come up with an option which is different than what has been done in the company before, and that can become your contribution to the organization. The other thing which is very important is that whether we want it or not, the group that we work with, after a while, they evaluate us and they know what kind of a person we are, whether we are truly interested in what we do, are we truly trying to solve problems, or we're just there because we want to get a paycheck at the end of the month. And I would suggest to you that those of us who are truly interested in what we do and trying to contribute to the organization are the ones who move ahead and get ahead in the company, in the organization. All right, I think we're ready for questions, and I will look to see what are I'll look at the, one question. This is an excellent question. What type of problems can you see in the oil and gas industry right now?
Okay, when I look at this, I see that we don't thoroughly understand fracturing in terms of how to make it work in the specific reservoirs that we deal with. We're too much about, we want to Xerox off or copy one program and use it everywhere. And you've got to understand the geology, a little bit about the geomechanics, look at the rock fabric, how this behaves. Is this solution that you're trying to push down the well, is this the best solution? Can you see things that you could improve? It's like the microproppant, it's the fluid types, it's the knowledge of how the products react. There's a lot of different things, but you have to continually learn. One of the things that came up years ago is we had a lot of people that were coming out educated, but very proud of their degree. And in my case, I have a master's in petroleum engineering from the University of Tulsa, but I have learned more in the field from applying technology and then looking at where it succeeded and especially where it failed. And that's an important piece. To me, your education begins when you're confronted with a problem to which the answer is not in the back of the book and needing an equation that has never been written. And it's understanding these basics as you go along that really push this thing forward.
Yeah, and if I may add, although we are drilling horizontal wells and fracturing them all the time, really how the fracture propagates is not properly understood by the industry. People have got an idealized picture of how the fracture is growing, but they don't really know how it grows. Now, as we dig deeper and deeper into the mechanics of fracture propagation and into the field data, we're beginning to understand it better, but it is still in the, at least for many people who are doing it every day, and even some of the service companies, they don't really know how the fracture actually propagates. And the techniques that have been used in the past, which is just to pump more and more fluid and more proppant, they have reached the limit. Now, in my opinion, we are right now overdoing all of them. I like to just share with the audience a couple of examples of the past history. Horizontal well drilling was done as the first horizontal wells were drilled in the 30s and 40s, and people drilled horizontal wells with the idea of getting better production from the regular reservoirs. Russians tried it for a while, and their wells were not that much better. We tried it here, West Virginia, Pennsylvania, and we were not doing any better than they were. And so the subject dropped. It was rejuvenated in early 80s by APPIH. APPIH is a French company, and they had a reservoir in the Rospo-Mary field, and they were faced with a real question, and that was, sometimes they drill these wells and they get very, very nice wells, and sometimes they drill these wells and they were dry. And they didn't understand why is it that some wells are dry and some of them are gushers, very good producers. And as they started to look at it, they came to the conclusion that the reason is because their reservoir is naturally fractured. And it has got a bunch of vertical natural fractures. If they drill into those fractures, they get good reservoir. If they don't, they've got a dry well. So they sat down and talked about it, and they finally decided maybe a better approach would be to drill a horizontal well. Why don't we drill a horizontal well and intersect these vertical fractures in the reservoir and then get a good well? They did it, and they were successful, very successful, and it worked. But the technology was not adopted by the rest of the world. They just said, okay, that's for the Rospo-Mary field, for those reservoirs. It doesn't have that much application for us. This went on until early 80s. In early 80s, there was a sudden drop in the price of oil. And the price of oil, which was at that time was trading at $20, $25 a barrel, they dropped it, the Saudis dropped it to about $6 to $7 a barrel. And at that, the intent was to make the North Sea reservoirs uneconomical because the lifting cost in North Sea reservoirs, just the lifting cost was $6, $7 a barrel. So they did drop the price of oil to discourage drilling in North Sea. Well, the group of engineers who were working with Maersk at that time, Maersk is a shipping company. A group of engineers who were working with Maersk thought that, hey, why don't we apply that same technology to our offshore wells, which we're drilling inclined? We can drill them horizontal and put multiple fractures in them and get better reservoirs. They did it, and they were very successful. But that same technology was not adopted in the United States. The same companies that were using them in North Sea, they would not use the same technology in the United States. They said those are for North Sea reservoirs. They're not for American reservoirs. And it was not until the unconventional reservoirs began to be developed in this country that we took it and adopted it and used it. So one thing I would say is if you keep your eyes open, there are problems all around that can use some creative thinking. Here is another question. Where do you see the need for hydraulic fracturing by fluids other than water? Do you expect water is effective when the clay content in the inorganic material is high?
Well, I've seen wells fractured with gelled water, cross-linked gel water, just slick water, just a little bit of friction reducer. We used to fracture wells with oil in a couple of places, diesel and emulsions of diesel and water or condensate and water. There's been a lot of different things used over the years, including liquefied gases such as propane and butane and under pressurized systems, etc. But in some cases, like extremely water-sensitive reservoirs, the oil-based or gas-based materials have a very good advantage. However, you're always faced with the cost, and that cost is a huge factor as you start using 5 million, 10 million, 15 million gallons of fluids. One of the things that we could use here is really understanding the reservoirs in terms of where is the best place to put the fractures, where's the best place to put the well, and then how many fractures. And Ali, I agree with you completely that we are over fracturing. And basically what I am kind of pushing some of our customers to do is to, instead of putting a barrels a day per fracture or something of that realm, put it back to what's it costing me to get that barrel of fluid. And when you work on that type of a guide point, you can see that there's a lot of operations that will return good cash, but you're having to really refine how you apply them. So, and there's some danger in any of the oil-based. I was looking this morning at some of my slides. I've been putting together some training courses, and I came upon two pictures of fracturing pumpers. The whole fleet had been burned to the ground. And one of these was a gasoline leak, but the other was from the condensate that they were actually pumping in some of the early tight gas wells. So there are some real good alternates to frac fluid, but it always comes back to how much does that cost in relation to another material. But you need to add one piece on there, is how much does it cost per barrel of fluid that is produced. And I think we need to normalize almost everything we do when we're in a tight situation like this. We need to normalize this back and really see what each of these operations is actually costing us, each of the fluids, each of the proppant, et cetera, and how effective is it at making money. We seem to be real good at spending money, and in some cases we're not good at making money. We need to watch that.
Yeah, and if I may add, over the years, there have been a whole variety of fluids that have been used for hydraulic fracturing, oil-based, water-based. Actually, the very first fracturing treatment was done with kerosene. They used kerosene for a frac fluid. And they used napalm for gelling it.
That's right.
Nobody would dream of.
I knew the guys. I knew some of the guys that were on that first well.
Yeah, I met some of them too, in fact. But CO2, nitrogen, alcohol, all sorts of surfactants, all sorts of fluids have been tried. The deciding factor today is exactly as George said, it's the cost. We are pumping several million gallons of fluid. It is the preparation and processing of this at the well site. If you were going, for example, the question was asked using CO2 for fracturing. CO2, if you're going to use CO2 for fracturing, the conventional, the known methods require CO2 to be hauled in on location in liquid form. Imagine if you're going to make a CO2 frac job, how many CO2 tankers you're going to have on location in order to do the work. And of course, the cost of that. The other thing to also consider is that these jobs, in the old days, we used to do a frac job in an hour, 2 hours. Nowadays, with these horizontal wells and the processes that we are using, some of these frac jobs take over a week. And if you are using equipment, mechanical equipment and processes for a week, there is always a risk that something may not function properly. And unfortunately, in our present system, even the smallest hiccups are worth $250,000. It is expensive to have any kind of hiccups during these treatments. So people are generally trying to use the most mundane, the most common, and the most simple system to use during their operations in order to also reduce the risk of any kind of mishaps, as well as, of course, in order to control the cost. I think we have run out of time. We have taken a little bit more than the 30 minutes we were planning. George, thank you very much. You always exceed what anybody else could have done. And thank you. It's very nice to hear from you. And I also want to thank Mr. Hamidreza Samouei, who has organized and taken care of this. Thank you. You have been very kind. He's been chasing us for some time and making sure that we show up and that we do things on as we're supposed to. This has been a very, very useful discussion. Thank you very much, and goodbye from me, and I'll turn it back to Mr. Samouei if he has got something he wants to add.
Thank you so much. I really appreciate your acceptance that you join us for today. Just for audience, the recorded version of this discussion will be available maybe by end of today in the social network of the APPIH. Thank you and have a great day.
Thanks, everyone.
All right, and thank you.
Thank you.